The next time you're at the grocery store and you grab a bottle of milk or a bag of chips, just stop for a second. Think about how that product actually got into its package. Because behind pretty much every single item on those shelves is this whole world of incredible high-speed engineering. So let's dive into that hidden tech.
I mean, really think about that number, 800 bottles a minute. That's more than 13 bottles every single second. It just sounds impossible, right? But this isn't just about raw speed. It's about an absolutely mind-boggling level of precision, hygiene, and the science that keeps our food safe.
All right, to really get this, we have to start at the very center of it all. In any modern packaging line, there's one machine that basically runs the whole show, that dictates the pace and the quality of everything else. And that's the filler.
Yeah, you can literally think of it as the heart of the entire operation. Every other piece of equipment on that line, from the machine that cleans the bottles to the one that slaps on the label, it all has to keep up with the filler's rhythm. And as we've shifted from, old school materials to things like plastic bottles and pouches, the demands on this heart have just grown like crazy.
So, what are these machines really up against today? Well, they have to be faster than ever. They have to be cleaner than a surgical suite to guarantee hygiene. And they've got to be smart enough to actually extend a product's shelf life. Not to mention, they need to handle a huge variety of package shapes and sizes, and even make it possible for some products to sit on a shelf for months without ever needing to be refrigerated.
Let's kick things off with a classic, the bottle. How in the world do you fill millions of them perfectly? Well, one of the most clever methods out there, especially for non-carbonated stuff like juice or wine, uses a force you can't even see. It uses a vacuum.
Okay, but before any of that magic can happen, the mechanics have to be flawless. And this piece here, the star wheel, it basically acts like a traffic cop. It grabs each bottle from the conveyor belt one by one and places it in the perfect spot on this moving platform.
And this is where the physics it's brilliant. So the platform lifts the bottle up, pressing its mouth against a rubber seal, making it totally airtight. Then, a vacuum pump sucks all the air out, creating this low-pressure zone inside, and since the liquid in the tank is at normal pressure, it's just naturally drawn into the bottle to fill that void. And get this, the filling stops automatically the second the liquid level covers the little vacuum tube. No timers, no complicated sensors, just pure, simple physics.
Now, this simple method has two massive advantages. First, because you're not forcing liquid in and pushing air out, you get a perfectly clean, foam-free fill every single time. And second, it's a built-in quality control system. If a bottle has a tiny chip on its rim, it can't create that airtight seal. And if there's no seal, there's no vacuum, and the machine just doesn't dispense any product. That means absolutely zero waste on damaged bottles. So smart.
Okay, so filling a bottle that's already made is one thing, but what about all those products in pouches, like milk pouches or bags of snacks? For those, the machine has to actually create the package and then fill it all in one seamless motion, and that takes us to the next level of engineering magic.
This right here is the Form Fill Seal Machine, or FFS for short, and it is the ultimate multitasker. It starts with a flat sheet of plastic film from a giant roll, which is way cheaper than buying pre-made bags, by the way. And then it shapes it, fills it, and seals it shut. The efficiency is just off the charts.
So how does this whole dance work? The machine pulls the flat film down and wraps it around a forming tube, creating an overlap. A hot vertical sealer comes in and fuses that seam together. Then a set of horizontal jaws clamps down, sealing the bottom of the tube to create the base of the pouch. The product drops in. Then, those same jaws move up, seal the top, and cut the finished pouch free, all while creating the bottom seal for the very next pouch. It's just this incredible continuous cycle.
Now, the secret to keeping this whole thing flowing smoothly is a little component called the nip rollers. See, after each pouch is filled and sealed, these rollers grip the plastic tube and pull it down by the exact length needed for the next one. It's that precision that makes sure every single package is exactly the same size, perfect for stacking on a pallet or a store shelf.
And this just gives you a little peek into how complex this whole operation is. The operators have to perfectly balance the temperature of those sealing rods, the exact timing of the jaws, the precise amount of the fill, and the speed of the film itself. If you get just one of these variables slightly off, the entire high-speed line can grind to a halt.
All right, now we're going to look at the real cutting edge, aseptic filling. This is the technology that lets things like juice boxes and cartons of milk sit on a regular shelf for months without going bad. It's an absolute game changer for reducing food waste and making global supply chains possible.
The whole concept here is basically a sterile triangle.
First, the product itself, like the juice, is sterilized with a flash of high heat. Second, the packaging material, like the carton, is sterilized as it enters the machine, often with something like a hydrogen peroxide vapor. And third, the entire filling process happens inside a completely sterile, pressurized chamber. If you eliminate every single microorganism, you eliminate the need for refrigeration. It's that simple.
And we are not just talking about little juice boxes here. This technology works on a massive, industrial scale. Some aseptic fillers can handle these enormous sterile bags, filling up to 1,000 liters. That's over 260 gallons of product into a single, shelf-stable container. Just incredible.
So in these huge bulk fillers, the key piece of hardware is often this cantilever arm. This arm reaches out and holds all the critical parts: the filling valve that docks with the bag's nozzle, the jaws that seal it, and the vacuum lines that remove the air before the fill starts.
And maintaining that sterile environment is absolutely everything. This quote really gets to the heart of it. For any surface that's going to touch the product, they use very specific materials, like this ASI 316 grade stainless steel. It's a special alloy that is super resistant to corrosion, and it's incredibly easy to clean, which is essential for guaranteeing that perfect hygiene.
Of course, all of this amazing hardware needs some serious brain power to run it, so the final piece of this puzzle is the smart systems, the software that controls, monitors, and even cleans these incredible machines.
Yeah, modern fillers are just packed with advanced tech. Operators use simple touchscreens to manage the whole process. The machines can actually clean themselves automatically. Alarms will sound if any part of the process deviates even slightly. And everything is logged, creating this detailed history of every single operation for quality control.
And one of the biggest innovations when it comes to care and maintenance is this: Clean in Place, or CIP. Instead of an operator having to manually strip down the machine to clean it, which takes hours and can introduce contamination risks, they just fit a special adapter. The machine then runs a full automated cleaning and sanitizing cycle all on its own. It's way faster, much safer, and a whole lot more reliable.
So here's really the main takeaway. Whether it's the clever physics of a vacuum filler, the mechanical ballet of a form-fill seal machine, or the sterile precision of an aseptic system, this whole thing is a world of unseen engineering. It's the technology that makes sure the food and drinks we buy are not only convenient, but are safe and accessible to people all over the globe. It really makes you wonder, doesn't it? As we push for more sustainable options, less plastic, and even greater efficiency, what kind of new engineering marvels are going to be at the heart of the packaging lines of the future? What's next?